In the last class, we introduced the assignment problem and we started solving a 4 by 4 assignment problem, which is shown on the left hand side. We said that the solution will depend on two very simple ideas. The first one being, if we make assignments in 0 positions and if we are able to get a feasible solution, which means every row has an assignment and every column has an assignment, then such a solution will have 0 cost and therefore will be optimum so long as all costs are greater than or equal to 0. We also observed that there are no 0 costs in this matrix. So, we said we will now reduce this matrix to another matrix, and we did that by subtracting the row minimum from every row and column minimum from every column and got this resultant matrix. Now, this resultant matrix which we have here, now this resultant matrix that we have here now has a 0 in every row and has a 0 in every column. Therefore, this is a matrix using which we can make the assignments, and we try to make the assignments in 0 positions and see whether we can get a feasible solution, which means we will now make assignments only in the 0 positions and then see whether we can get 4 assignments such that every row has 1 assignment and every column has 1 assignment. Now, let us do that. Now, let us take this matrix and start making the assignments. So, the same matrix is shown here. The first row we observe that 4, 2, 0 and 1, the first row has only 1 0 and therefore, we can make an assignment here, which is shown in blue color, and we can make an assignment here. Now, the moment we make an assignment, which means the first row we have made an assignment, the third column also has an assignment. Therefore, the third column we cannot have an assignment here. Now, that is shown through this. So, this one we cannot have an assignment. Now, I see whether I can make an assignment in the second row. Now, the second row has 2 0 positions. We made the assignment in the first row because there was only 1 0 position. So, we made the assignment. Now, there are 2 0 positions. So, we can either make the assignment here in the first position or we can make the assignment here. But at the moment, if there are 2 zeros, we temporarily not make an assignment and proceed. The third row also has 2 0 positions and therefore, we do not make an assignment to begin with. Then we go to the fourth row, and the fourth row has only 1 0 and therefore, we can make an assignment. This assignment is shown in the blue color and I am also marking it inside a box. So, in the fourth row we have made an assignment. So, this is already assigned. So, the blue color shows it is already assigned. So, I am just making another box over there, it is already assigned. Now, since the fourth row has an assignment in the second column, the second column cannot have one more assignment and therefore, this will also go, and that is shown by another x which is there. So, right now we have made 2 assignments and there are still some zeros that are left. So, we now start looking at it column wise. Now, we start looking at it column wise and see what we do. Now, we realize that we had already made assignments here and here already. So, if I look at the first column has only 1 0 and therefore, I can make an assignment here. Now, when the first column has only 1 0, the assignment has been made, row 3 now has an assignment and therefore, we cannot make an assignment here. Now that is shown by another x that is coming here. So now go back and repeat, the second column is already assigned, the third column is already assigned, the fourth column has only one assignable 0, so we make an assignment in this one. We can also see this, and once we put this, now we will have 4 assignments that are shown in blue color. So we first started with this assignment, then we did this assignment, then we did this assignment, and then we did this assignment. So the assignments are shown in the blue color as well as in the red box. So now we have made 4 assignments. We have made assignments only in the 0 positions, and every row and every column has one assignment, and therefore this is a feasible solution. Now this 4 assignments correspond to x13 equal to 1, corresponds to x13 equal to 1, this position, first row third column, x13 equal to 1, x24 equal to 1, x31 equal to 1, and x42 equal to 1. These are the 4 assignments that we have made. Now we have got a feasible solution with 0 cost in the reduced matrix, therefore it is optimum to the reduced matrix, and therefore it is optimum to the original matrix, because we got the reduced matrix under the assumption that the solution to the reduced matrix is the same as the solution to the original matrix. So again, to repeat, these are the 4 assignments. So to repeat again, just to show the assignments within the box, this was our first assignment, this went off, this was our second assignment, this was our third assignment, and this is our fourth assignment in this order. So when we made the first assignment, this was eliminated, then when we made the second assignment, this one was eliminated, when we made the first assignment, this 0 was eliminated, when we made the second assignment, this was eliminated, when we made the third assignment here, this was eliminated, and then we made the fourth assignment. Now this is optimum to the reduced matrix, this will also be optimum to the original matrix. So the positions where the assignments have been made, the costs are shown here. So the cost of the assignment is 4 plus 8 12, 12 plus 9 21, 21 plus 6 27 is the total cost, which is the cost corresponding to the optimum solution. And the optimum solution is given by x13 equal to 1, x24 is equal to 1, x31 is equal to 1, and x42 equal to 1 with objective function value equal to 27. So from the first example, what we understood is a very simple way to solve the assignment problem, where we start with a given matrix, we reduce the matrix by subtracting the row minimum from every row, column minimum from every column, such that we get 1 0, at least 1 0 in every row and every column. Start making assignments. First start by looking at the rows and then look at the columns and so on. If there is only 1 0, if there is only one assignable 0, then make an assignment, which is what we did. We started again to repeat the process. We started with this assignment because there is only 1 0, therefore this got automatically cancelled. Now the second row had at that point 2 zeros. So, we did not make an assignment. The third one would also have 2 zeros, we did not make an assignment. This one has only 1 0, we made an assignment and cancelled this. Then we went back to the column. Now, the column has only 1 0, we made this assignment and cancelled this. These two columns were already assigned. Now, this had only one assignable 0, which is here, and we made the assignment and realized that we have got 4 assignments, which means we have got a feasible solution, and then we gave the answer. Now, the next question is, will this happen every time we solve an assignment problem, or can something else happen? Obviously, something else can happen, and we see what can happen, which is very different from what we have seen. We will look at it through another example. So, we will now go to the second example and try to solve a similar but different looking assignment problem. So, this is our second example, which is again a 4 by 4 assignment problem with slightly different cost coefficients. So, again we can say that this represents the 4 jobs, this represents the 4 people. So, again based on the same two principles, we will first try to subtract the row minimum from every row and column minimum from every column, and try to get a matrix that has at least 1 0 in every row and every column, and we will make assignments with such a matrix and see whether we can get 4 assignments or see whether we can get a feasible solution that would have 4 assignments. So, that is the method. So, first thing is we subtract the row minimum from every row. The row minimum in the first row is 4. So, we subtract 4 to get 4, 2, 0, 5 and so on. The second row, the row minimum is 5. So, it will become 2, 0, 1, 4 and so on. Third row, the row minimum is 9. The fourth row, the row minimum is 6. So, we get from the first row we would get, subtracting 4, we would get 4, 2, 0, 5, which you can see there. Subtracting 5 you will get 2, 0, 1, 4. Subtracting 9 from the every element of the third row you will get 0, 1, 2, 3, and subtracting 6 you will get 3, 0, 2, 5. Now, we start looking at the columns and subtract the column minimum. The first column, the minimum is 0, so we retain it. Second column, the minimum is 0, we retain it. Third column, the minimum is 0, we retain the column. Fourth column, the minimum is 3, so we subtract 3 to get 2, 1, 0 and 2. So, this is the reduced matrix after we subtract the column minimum from the fourth column. Now, we can start making assignments in this matrix, and we will start doing that. So, I have given the matrix as it is. Now, we look at the first row. The first row has only one assignable 0. We make an assignment which is shown in the blue color, and again let me add the box just to show that it is an assignment. So, we have made our first assignment, and because of this first assignment there is no other, the first row is assigned to the third column, but there are no other zeros here. So, we keep it as it is. Now, we look at the second row. Now, we look at the second row and then we realize we already made an assignment here. First assignment was here, just showing it by a box, and now the second row has only 1 0. Therefore, we make another assignment here. So, we have made an assignment here. Second row goes to the second column, and because we have made this assignment here, we have to cancel this 0 because the second column can have only one assignment, and that is given by this red color X, which cancels out this 0. Now, I go to the third row and I observe that there are 2 zeros. So, I will not make an assignment. Now, I go to the fourth row and I realize that there is no assignable 0 for the fourth row. Now I come to the first column, there is 1 0 here, so I will make an assignment. So that is going to be shown in the same table here. So again I will look at mark all the assignments. This was our first assignment, this was our second assignment, which cancelled out this x, and then we look at the first column and we make an assignment here. So when we make this assignment here, automatically this will go, because by making an assignment in the third row first column, the first column has an assignment, the third row also has an assignment. So this 0 is not going to add value, and that is again shown with the red one coming in. So now we go to the second column, it is already assigned, third column is already assigned, the fourth column does not have an assignable 0. So if we keep repeating looking at the rows and columns, we realize that we cannot make any more assignment. We can't make any more assignment because all the zeros in this matrix have either been boxed, which means they have been assigned, or they are crossed, which means they are not fit for assignment. So we need to stop the assigning procedure at this point, and we observe that we have made only 3 assignments as against 4 that we wish to actually have. So we have not yet got that feasible solution. Remember that we will make assignments only in 0 positions, we will not make assignments in the non-zero positions. For example, the fourth possibility is this 2. So we will not make an assignment in this 2 and say that we have got a solution. No, we will make assignments only in 0 positions, because we are working on a principle that if I make assignments in 0 positions and I get a feasible solution, then such a solution is optimum, because the cost associated with that is 0. So we need to do something to this matrix to get another matrix, and then we need to make assignments in the other matrix. So what do? Now we make some changes to this matrix by using a procedure. So let me start that procedure now. So we would now say that we make some ticks, and we are going to draw some lines based on an algorithm. So tick an unassigned row. So this fourth row does not have an assignment, tick an unassigned row. Now if there is a 0 in that row, tick the corresponding column. There is a 0 here, tick the corresponding column. So tick the corresponding column. Now this column has been ticked. If there is an assignment in that column, then tick the corresponding row. So this row will now have to be ticked. Again, if there is a 0, tick that column. So there is a 0, but the column is already ticked. Therefore no more ticking is possible. So again let me repeat the procedure. Tick an unassigned row. If there is a 0 in a ticked row, then tick the corresponding column, if it is not already ticked. If a column is ticked and if there is an assignment, tick the corresponding row, if it is not already ticked. Repeat this procedure, that is the new thing, and we will show this here. Tick an unassigned row. If a ticked row has a 0, then tick the corresponding column. If a ticked column has an assignment, then tick the corresponding row. Repeat these 2 steps such that no more ticking is possible, and draw lines through unticked rows and ticked columns. Now I have drawn these lines have been drawn through unticked rows. This is an unticked row, this is an unticked row, and ticked column, this is a ticked column, this is a ticked column. So we have drawn lines through unticked rows and ticked columns. Again to explain it, tick an unassigned row, this was our first tick. If there is a 0, tick that column, this was the second tick. If there is an assignment, tick that row, this was the third tick. Now repeat these steps 2 and 3, no more ticking is possible. Draw lines through unticked rows and ticked columns, unticked rows and ticked columns. If we do that, we observe something interesting. Now, in this procedure of drawing the lines, we have now drawn 3 lines, and you will realize that there are 3 assignments. There are 3 assignments shown in blue color, there are 3 assignments, and we have drawn 3 lines. Not only that, the 3 lines will cover all the zeros. All the zeros in the matrix will have at least one line passing through them. We may have non-zeros also covered, but the important thing is every zero is now covered by one line. So, we have now made the ticks and we have drawn the lines. Now, we have to do something with this to generate a new matrix with which we will actually be solving this problem. Now, what do we do after this ticking and how do we modify this to get into a new matrix? We will see in the next class.